Today I'm working on an ECU from a Skoda Octavia 1.6 diesel engine. This is the PCR 2.1 engine control unit. The problem with this unit is that there is an issue with the output for the engine control relay, the ground for the coil of the engine control relay to activate the coil. This ECU won't supply it, and as a result the engine won't start. How this works: the unit receives terminal 15 plus 12 volt line and the ground, and then it should supply the ground for the activation of the engine control relay, in order to have here on the big pins the terminal 30, and this isn't happening. So I'm gonna start by measuring some things, and I'm gonna compare with a good working ECU, the same one, and we'll take it from there. Okay, I just powered this terminal 15 and ground. There are two terminal 15s in order to have on this pin A69 ground for the engine control relay. If you look at the wiring diagram, this is the engine control relay. This is the engine control relay, and this is activated by the ECU down here on the pin A69. On the coil we have 12 volts, and here we should have ground. Okay, the unit is powered up. We should have on this wire ground for the engine control relay. One probe, the probe ground here, and one here on the 12 volt line, and we have 0.00 volts. Let me check with the ground. 0.098. Okay, so we got nothing on this pin. When the terminal 15 is on, we must have ground, so we don't. I'm gonna check with a good working ECU. Let's cut the power and move the pins from this side to here. Ground here, and here 12 volt, and you see 13.78 between the 12 volt line and this pin. Power off. So 100% an ECU problem. The customer is from France, and he watched many videos on my YouTube channel. So he contacted me and sent me this unit over to take a look at it and try to repair it. Multimeter in continuity mode. and I want to know which driver of this is responsible with the ground for the engine control relay. Maybe this signal is coming from the processor. Let me check on this working ECU. And I think I'm gonna get the board out to see on the back. Okay, after testing, I was able to find the pins. Okay, I was able to find the circuit. This is the pin. It goes to this resistor. The value of this resistor would be 10 kilo ohms, 9.93 is good. And then it goes from here to here in this diode. Let's check this diode. Diode mode. We have 0.5 voltage drop, and the diode is good. And then it goes right here. Let's check the trace. Continuity mode. Okay, so trace is good. This chip is responsible with the activation of the relay, and I can see something burn on that chip. Can you see? Can you see? Let me zoom in. Maybe we can see more or better. And yes, you can see some burn marks on that writing, that white, and some cracks or holes, little holes. That's an indication of a burnt chip. And yes, we have holes here and cracks. Okay, I'm gonna go ahead and replace that chip. I have a donor board right here. I have a donor board, and it's this, and it's the same chip. I'm gonna change the lens. Okay, now we can see more, not all the chip, but it's a little better. I'm gonna go ahead and desolder this, and I'm gonna solder it on our board. I'm applying 350 Celsius degrees. Although it's a thick board and this chip has a radiator, I'm not gonna use low melt solder. I think it will come off easy. Okay, so we got the chip out, and I don't want to take out this board of its case, and I'm gonna use low melt solder to desolder that, because it's very hard to get this board on the melting temperature of the unleaded solder. I think with a hot air station it's gonna take half an hour maybe to take this out. Maybe with the preheating station on, it's a little quick here. It's a little better, but I don't want to do that. I want the easy way. Let's apply some flux. And now I'm gonna apply a little bit of low melt solder, and the low melt solder will mix with the unleaded solder from the factory, and the melting temperature will drop. That's enough here. I got the capacitor out. I'm not gonna leave it like that, because now it's soldered with low melt. I'm gonna clear the solder from here and put in some leather solder. It's important on this radiator Okay, finally the chip is out. And place the new chip here. Apply flux. Solder the corners to keep it in place. I think I should apply solder here in the middle and here. Now I want to reflow and settle the chip down in place. Okay, this is the chip that we replaced. It looks good. Now, meter in voltage mode. Let me plug the power supply. Right here. And the moment of truth. Let me put the probes. One here and one over here. And now I'm gonna hit the power button. 1, 2, 3. And yes. Wow. 13.8. Now we have ground for the engine control relay to send or supply this unit with terminal 30. Wow, very nice. I'm happy. Let's turn on off the power supply, and I want to check again. Turn on. 13.8. Wow, very nice. This ECU is saved. What I want to do now is to check on the diagnostic tool. I want to check that error about processor fault, and I hope I can erase that. I checked again because I had this terminal 30 power on, but I took it out and we still have 14 volts. Okay. Now I just want to check the DTCs on the diagnostic tool. 5 and 6. The BCDS is connected here. Power on. Terminal 30 right here. Okay, the unit is done. I think it will work without a problem. The errors cannot be erased on the bench because of immobilizer issue on the bench. But I'm gonna assemble it and send it back to the customer. So that's it for this video. Thank you for watching.